Hello, my name is Frances Laureano de Leon. I am a PhD student at the School of Computer Science at the University of Birmingham in the UK. I will be introducing our work titled Code Mix Probes Show How Pre-trained Models Generalize on Code Switch Text. This work has been accepted at LREC Codelink 2024. So today I will be giving you a little bit of context. I will be introducing the research question for this work. I will be going over the background, namely, I will be talking about the tools that we use to carry out our experiments. Then I will talk about the experiments and the results, and I will finish by concluding this talk. To begin with, we are dealing with code switch text in this work. So code switching is a phenomenon in which multilingual or bilingual individuals alternate back and forth between languages. In this comic, we have an example of Spanglish in the last panel. For Spanglish, marque the number 3. And the reason for this is because I think it's a very nice way of introducing code switching, but also we are dealing with Spanish-English code switch text. Here we have some more examples of what this text looks like written. These have all come from X, formerly known as Twitter. I will be using the terms interchangeably during this talk. And the reason I'm showing you these tweets is also so you can see the example of the kind of text we're using to train our models and the kind of text we're using for our experiments. So what are we trying to find? Namely, we're trying to find what PLMs or pre-trained language models encode or capture about code switch text. And we do this by exploring three things. We explore how models can detect this code switch text. So do the models have this information inside of them? Can they tell the difference between code switch and monolingual text? We look at syntax, namely, we're looking to see whether PLMs are structuring, or the structure that you can extract from PLMs resembles more the structure of one of the source languages when compared to the other. And we are looking at semantics. Specifically, we want to see how consistent PLMs are at representing the meaning of code switch text when we compare this to the way PLMs represent the meaning of that same text in the source languages. And I will be talking about each of these in a little bit more detail later on in the talk. And to do this, we need a few things. Firstly, it's not on the slide, but we are using PLMs. Namely, we're using multilingual BERT and XLM Roberta base and large. And in order to explore the representations or to explore these models, we are using probes. We're using 3 different kinds of probes in this work. Firstly, we're using linear probes for the detection tasks. We're using a structural probe to explore the syntax of code switch text. We're then using the semantic probe in which we train a model in semantic text similarity. And I will be talking about that in detail when I dive into our experiments. We are also needing to use data. We use, for CodeMix data, we're using Sentimix Spanglish data set. We're using the Calcs 2021 data set in Spanish and English again. And we're also using a parallel corpus that we have created as part of this work, because for the structural and semantic tasks, we do need a parallel corpus where we have code switch text and then the translation in Spanish and English. And this is something that we were not able to find and to our knowledge, didn't exist until we created. So for the detection tasks, these consist of training a linear probe in sentence classification task and in a token classification task. For the sentence classification task, we're trying to see whether models have encoded the difference between monolingual and code switch text. We look at the difference between using the CLS token versus mean pooling. And we're also doing a token classification task, which is a language ID task. And what we're trying, the way that we set up this task is that we're training a linear probe to tell us whether a token is in Spanish, English, or other. Why other? Because code switch, because it's not always straightforward whether something is in English, Spanish, or code switch. For example, the word chocolate is spelled the same way in Spanish and English, and it is difficult to tell whether that token is in Spanish or English. And what we're doing is a layer-wise exploration. So we take the representations layer by layer for each PLM. We freeze the weights, we train a linear classifier. And we see in these results that from very early on, for both tasks, the models seem to be able to tell this difference, or the models seem to have this information encoded in them. And so the probe is able to, we get a good F1 score for the probe from very early layers. We see here, even though we do have a good F1 score, we see that the multilingual bird struggled a little bit for the Senti mix. So that's that Spanglish data set from the SEM eval task. And the reason we think that this happened is probably because, and you see that these two lines as well, this is the model F1 score for Sentimix, is that this data set has more mixed intrasentential code switching happening than the LINS LID data set. We then look into the syntax of code switch text, and we do this by using structural probes. So we are using Hewitt and Manning structural probe. We train it in English, monolingual English and monolingual Spanish. So we're training an MBERT model in Spanish and English dependency parse task. And what we do is that we then take our parallel corpus that we have created. Here is an example of one of those sentences with the translations, and we give it to this structural probe, and we get the dependency parse for code switch, English, and Spanish. And what we do is that we are trying to get the graph edit distance in order to compare the distance between code switch and English and code switch and Spanish. Because just to remind you, what we're trying to explore is to see whether the code switch dependency parse is more like the Spanish dependency parse or the English dependency parse. And we use graph edit distance because what we're trying to see is how many changes you have to make to the code switch graph, for instance, in order for it to look like the Spanish dependency parse or the English dependency parse. And what we find is that there is a high correlation between the distances in Spanish, in Spanish and code switch and English and code switch. We then also see that when we use synthetic code switch data sets and we do the same comparison with English and again with Spanish, that this correlation starts to drop. And what we can see with this first result is that the model seems to not be structuring code switch text more like one language when compared to the other. And so that models might be representing code switch text in a way that doesn't necessarily align with the theories about how bilinguals structure code switch text. Lastly, we look at a semantic text similarity task. We train our PLMs, we fine-tune them on semantic text similarity in Spanish and English. And what we're trying to do is that we're trying to test the consistency in the representations of monolingual versus code switch text. What we're trying to do is simply, if we're looking at this equation here, what we're trying to see is whether the similarity of a sentence, for example, an English sentence I and an English sentence J, whether that similarity approximates the similarity between a code switch sentence I and a code switch sentence J. These sentences, the English I and code switch I, are translations of each other. And the sentence J in English and sentence code switch J are translations of each other. And if the models is consistent in representing the meaning of code switch versus the source language text, then these scores, these similarity scores will not be too far away from each other. And what we see is, in fact, there is a high correlation between the scores in English versus English and code switch versus code switch, Spanish versus Spanish and code switch versus code switch, and so on. So what we see is that models, even though they have not been trained on code switch text, are able to capture the meaning of code switch text, and they're able to do so in a way that is consistent with the way they capture the meaning of the source language text. So what do these results mean? What we see with these results is that models, PLMs, are able to structure and capture code switch text, even when they have not been explicitly trained on code switch text. We can see as well that models may be structuring code switch text in a way that doesn't necessarily align with popular code switch linguistic theory. For more details on this, I invite you to read our paper. We do go a little bit more deeply into code switch theories, or explaining what these are. And we can see as well that these models are able to capture the semantic meaning of code switch text. Ablation studies using synthetic code switch text also indicate that naturalistic code switch text may be necessary for these models to perform well. Going forward, we would like to experiment with other language pairs, such as Hinglish, which is a language pair that is not as closely related as Spanish and English. We would like to expand our experiments to using generative decoder-only models. We would like to generate synthetic code switch text using state-of-the-art models such as GPT-4 in order to generate a more naturalistic sounding code switch sentence. Thank you for listening to this talk. I invite you to read our paper for more details on the experiments with the synthetic data, as well as for more information in general of how we carried out these experiments. Thank you.